heap data structure, and first of all we see what is heap. So what is heap? In real world, the heap is heap, like you pile up some things, and that's called heap. Like this is the pile of these objects, and you have piled up these objects, so it is a heap. So what is the purpose of heap? The purpose of heap is very straightforward. When you want to find the maximum or minimum from a collection of objects, what do you do? What do you do in the case when you want to find the maximum or minimum from a collection? Say you have a bag full of toys, and you find and you want to find the biggest toy. So what will you do? You will empty that bag on a floor, and you will make a heap, and from that heap you will automatically find the maximum toy. So this is the main concept behind this data structure. We pile up those things in such a way that the biggest thing is automatically come at the top. So in computer programming, the technique to pile up the thing is a tree, a binary tree. So we use tree to make a heap, and the root is the greatest element or the biggest element in max heap, and in case of min heap, the root is the smallest element. And so this is heap, and now we study two properties of heap. Property one is that a binary heap, a binary tree, that is a tree of heap. Heap is a binary tree, and which is complete from left to right. Like I create a new file here. If you want to create a heap tree, what will you do? You will, so this is a root node, and next you will create a child, and that child will always be left, because we will complete this tree from left to right. So it's a complete binary tree from left to right, and once a level is complete, then we will move to the next level. So this is the first level, this is the second level, and then we will move to the third level, and we will keep completing it from left to right. So this is the left child, this is the right child, this is the left child, this is the right child, and so on. So this level is complete. Next we will move to the third level, and we will keep completing it from left to right. So for left child, right child. So this is how the heap is constructed, heap tree is constructed. This is the first property. And now the second property. This property is very interesting, and this property is that parent is always greater than children. So due to this property, we get that the root is always the greatest or the biggest element or the smallest element. Why? Look, this is the root, and if we move up from any branch, like if we move up from here, we will definitely end up at the root. Similarly, if we start moving up at this branch, definitely we will end up at the root. So if you start moving up from any branch, you will end up at the root. So in any branch, all the elements are if you compare all the elements with its parents, you will always end up at the top. So due to this, the property that every parent of the heap tree is greater than its children, make sure that root will always be the greatest element. So this is the property, the parents always greater than children. So when these two properties are met, we say that this binary tree is actually a heap tree, and its root has the value which is the biggest value of all if it's a max heap, and if it's a min heap, root will contain the minimum value. So now we study how we insert the data into a heap tree so that the biggest element is always on the top, and how do we delete the data. So first of all, we see how do we insert the data into a heap. The concept is same. We make a complete binary tree which is completed from left to right. Say we have data, like let me write data here. Say we have data 6, 10, 100, 5, 200, 7. Say we have this data and we want to make a heap, and when we will make a heap, automatically the biggest element should be on the top. So now let's see how does it happen. First of all, this is 6, we write it here. Adjust it so that we don't miss these values. So we write 6 here. Next we have value 10, and we will complete the binary tree from left to right, so 10 is here. So when we insert the next any value, we always compare it with its parent. So 10 is compared with its parent 6, and 10 is greater than 6. What we will do, we will swap these two values. We will simply pick it up and we will keep it, place it here, and we will place it here. Next we insert 100. So 100 will definitely come here. So here this is 100, and again whenever we insert a node, we compare it with its parent. 100 is greater than its parent, I mean 10, so again we will swap it. So 10 goes there, 100 comes here, and 10 goes here. Okay, so next comes 5. So where we will insert 5, definitely this level is complete, this level is complete. 5 will go to the third level, it will come here. So here 5, and now we will compare it with its parent. 5 is less than 6, 5 is not greater than 6, so we will do nothing and we will stop here. That's it. Next comes 200. It will land, it will definitely land at this point, but after putting it here, we will compare it with its parent, and its parent is 6, and 6 is less than 200 because it's a max tree, so we will move up if the child is greater than its parent. So 200 is greater than 6, so what we will do, we will definitely move it from here. Let's keep it here. 6 will come its place, and 200 will go in place of 6. So next we will compare 200 with 100, and 200 is again greater than 100, so we will swap it with its parent. So we remove 100 from here, place 200 at this point, and place 100 back at this point. So next comes 7. So we will place 7 will be placed here, and now we will compare 7 with its parent. 7 is not greater than 10, so we will do nothing. So this is the way that we are inserting nodes into a tree. And the interesting part is that whenever we insert a node, we compare it, suppose, with only with its parent. So if a node is inserted here, our comparison will go up this side. If it's inserted here, it will go up this branch. And interestingly, every node is for sure compared with the root node. So therefore, this technique makes sure that root is always the maximum always has the maximum value. So that's why root always contains the maximum or the minimum value in the case of max or min heap respectively. So this was insertion, and next we see how to delete. Deletion is because the heap data structure is normally used for heap sort. So in heap sort we use heap data structure, and we pop up the or you can say remove the top node, and next we mix the tree so that maximum is again pushed up on the top, and we again remove from the top. So now we see how should we remove the value from the heap, and how should we mix that heap again so that the next maximum is again pushed up on the top. So here the concept is we remove the top value, that's the maximum value, we remove it, and let's say we want to do descending we want to arrange these values in a descending order. So what we will do, first of all we will remove the top value and we place it here, and next when we remove the top value, what we do, we place the last value at that point, and that is 7, and next we compare this value with both of its children, left and right, and here and the biggest value is swapped. Like it has two children, 100 and 10, and 100 is big brother. So first of all we compare these two children with each other, and we choose the big brother. Here 100 is big brother, and next we compare that big brother with the parent, and 100 is greater than its parent, so we will swap these two nodes. I remove this node and place this node there, and copy this node here. And again 7 has two children, 5 and 6, and 6 is the big brother, and now we compare 6 with parent, and now 6 is less than 7, so we will do nothing and we will stop here. So next we remove this root node and place it here. So it is a heap sort that is being sorted in the descending order, and what we will do, we will place the last value at this point, and now the last value is 6. We place it here, and 6 has two children, 7 and 10, and 10 is a big brother, so we compare 10 with 6, and 10 is greater than 6, so these values are swapped with each other. 6 comes here, 10 comes here, and 6 comes here. So next what we do, we remove 10 and place it here, and the last value is placed here. The last value in this tree is 5, and 5 has two children, 7 and 6. 7 is big brothers, we compare 7 with 5, definitely 7 is greater than 5, so it is swapped with 5. 5 come here, 7 come here, and next 5 has no children, so we stop here, and next we remove 7 and put it here, and last value in this tree, that is definitely 6, is placed on the top, and 6 has only one child, and definitely 6 is greater than 5, so we do not swap it, and now we remove 6, and now 5 is the value that is put on the top, and 5 has no children, so 5 is the last value, and now finally we remove 5 and put it here. So using that heap data structure, first of all we push these elements into a heap, and then we remove those elements one by one, and now you can see it's a sorted list in the descending order. So this is the technique how we insert or delete elements into a heap, and in the next element we will see how we maintain a heap tree in an array data structure and how we implement it in C++. So for that lecture, stay tuned.